Okay, so this section is how we're going to prove that a quadrilateral is a parallelogram. And so we have 6 different ways that we can do this. We're going to do this video just talking about if we're looking only at the sides of a quadrilateral, how can we determine whether or not it's a parallelogram? The first way is really kind of obvious. So number 1 is if we determine through whatever series of steps that the opposite sides are parallel, then it's a parallelogram. So if both pairs of opposite sides are parallel, it's a parallelogram. And that seems really obvious, but that is the definition of being a parallelogram, is to have 2 pairs of opposite sides parallel. So if both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. And so again, that is really and truly just the definition of being a parallelogram, is that we have pairs of opposite sides parallel. Remember, these arrows mean parallel. Another way that we can prove that a quadrilateral is a parallelogram is if we have both pairs of opposite sides congruent. So if I can prove to you by any number of steps that the opposite sides in a quadrilateral are congruent to each other, then I can tell you that the quadrilateral is a parallelogram. So we've got opposite sides are parallel, opposite sides are congruent. We have a third way, and that is when opposite sides are both parallel and congruent. So we've got 3 ways we're talking about so far. 1, parallel, 2, congruent, or 1 pair, both parallel and congruent. So in this way, we've got 1 pair, and it doesn't matter which pair. It can be the top and bottom or the left and right, but I have exactly 1 pair, both congruent and parallel. That also makes me a parallelogram. So if 1 pair is both parallel and congruent, so parallel is the arrows, congruent is the tick mark, parallel and congruent, then my quadrilateral can be a parallelogram. Okay, our 4th way using sides is if the diagonals, and remember the diagonals go from one corner to the other, if the diagonals bisect each other, then my quadrilateral could be a parallelogram. So my picture would look like this. So maybe I'm proving 2 triangles congruent, the top and the bottom, or the left and the right. Maybe I'm proving this triangle is congruent to this triangle. Or perhaps I'm proving that this triangle is congruent to this triangle. And maybe by doing that, I'm able to use CPCTC and show that the 2 triangles are congruent, so the parts are congruent, and so the diagonals bisect each other. Or maybe the picture's just given to me, and the diagonals bisect each other. So if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay, so here are 3 of those ways that we just talked about. So this was number 2, this was number 3, and this was number 4. Remember, number 1 was just that definition of a parallelogram. And remember, the definition of a parallelogram is saying that the opposite sides are parallel. So if that information is given to you, then I can also say that I'm a parallelogram. So I've got opposite sides parallel. I've got 2 pairs of opposite sides congruent. I've got 1 pair of opposite sides is parallel and congruent, or the diagonals are bisecting each other. Now remember, this is just proving parallelograms using sides and diagonals. We can also prove parallelograms using the angles in the quadrilateral as well, and that'll be in the next video.